if I were to come in and take that second equation, subtract it from the first, you guys, don't I get cancellation all over the place? If I subtract the second from the first, I think diagonally these two terms cancel. So do these two. Actually, all the terms upstairs and downstairs cancel except for the first term upstairs. And maybe the last term downstairs. And so I think when it comes to S sub n minus r times S sub n, I'm merely going to get the difference between A and A times r to the n power. As a matter of fact, to find the value for S sub n, let me factor S sub n out. Divide both sides by what's being multiplied to it, and I think I'm merely left with this. And if you guys want to find the sum of a finite geometric series, you're just simply going to use this formula and put it in your back pocket. Oh shoot, I didn't mean to say that, did I? You already did that back in pre-calculus.
If we took pre-calculus.
If you took pre-calculus. But you know what, you guys, I don't want to stop here. I really don't want to discuss finite sequences, or excuse me, finite geometric series. I'd like to talk about the infinite geometric series. So can I massage this a little bit? So watch me. S of n interpreted as this one fraction. Minus this one fraction. It's just that if r is strictly less than 1 and strictly bigger than negative 1, don't you guys agree that as n increase that bound, that's going to go to 0? In other words, if I took the limit of the nth term of the sequence of partial sums, I think this whole second term is going to drop out if r is between negative 1 and positive 1. And I think the corresponding sum of the infinite geometric series is just an a over 1 minus r. It's a means by which I can actually compute the infinite sum, if the sum is geometric. Matter of fact, this is so important. Can I restate this? This is such a big deal. I'll make it official. Theorem. The corresponding infinite geometric series is exactly equal to a over 1 minus r if it is the case that r is somewhere between 1 and negative 1. And I think if r is not between 1 and negative 1, this thing right here is going to just blow up. And therefore, I'm not going to have a convergence for this geometric series. So, for example, I want a yes or no answer. Is that a geometric series? Yeah, I think it is, you guys, because no matter where you are in a series, you can generate the corresponding next entry in the series just by multiplying the previous term by -1/2. Matter of fact, I think it's a geometric series where r is equal to -1/2 and a is equal to 5. And so I think the sum of this infinite geometric series is nothing more than my a over my 1 minus r, because a is my first term, and r, sorry, we agreed r was equal to, in this case,
1/5.
say it again.
Or negative.
-1/2. So I think in the end I generate a positive, is that 10/3? In other words, you guys, I may have infinitely many terms in the series, but when I add them all up, all infinitely many of them together, I will come up with a sum of 10/3. Or you can say, if you just take n terms of this infinite geometric series, look at the corresponding finite geometric series, that sum gets closer and closer to 10/3 as n increase that bound. Oh, did I not number this correctly? Number 1. What about this example? What do you think? Does it look geometric?
Yes.
Yeah, I think it does. Matter of fact, I think it looks something like this. Matter of fact, maybe you and I should just take a break and massage that series so it looks like the standard form. In a massaging it, I want n to start at 0. Oh, it already is there. But I want something to be raised to the nice clean k, or in this case, nice clean n power. Who cares what the index variable is? So to do that, let me talk about a 5 to the n power upstairs. Is this okay?
Yeah. Well, you have to multiply
Well,
by 5.
as long as I shave off that factor 5 upstairs. What about downstairs?
You have to multiply it by 1/2.
Split up using my basic laws of exponents. But I think that's merely going to give me the sum as n ranges from 0 on up of something raised to the nth power, which in this case is 5/2, yes or no? Is that going to be strictly between 1 and -1? No, it's not. My a value out front ends up being, I don't know, what is the a value? 30? But since that r value and absolute value is not less than 1, then this particular series diverges. Do you guys agree? And how about this example? Now what? Is it really? What do you mean by the same thing?
Well, we just split the exponents.
So shave off -2 to the. I'm nervous. I'm nervous because technically speaking, at least with the author's standard notation, he likes to have the index variable start at 0, and I didn't. And so before I clean the inside of the sum, let's mess around with the starting value of the index variable. I think n is start. Since n is starting at +1, I can force a starting value of 0 if I make a change in variables. It's like substitution. Can you guys imagine what would happen if I replace n with k plus 1? Wouldn't it tell me that k plus 1 ranges from 1 on up? If I made a substitution replacing n with k plus 1. But now if I subtract 1 from both sides of this mini equation, doesn't that say that k is equal to 0 initially? Do you guys see my point? Let's be consistent then. I'm the one who said